Hello, can somebody confirm me that am I audible? Hello guys, am I audible? Can someone confirm me that am I audible? Hello, hello, hello. Yes, thank you, Nitila. Thank you so much. Okay. So hi guys, good evening, and I welcome you all to day 5 of Road to Java. And I hope that you had a very enjoyable Sunday. I hope that you all have enjoyed your Sunday. So now let us get back to our academics again, and let us have some fun with Java again. Mhm. So I'll wait for one more minute and we'll start. We'll start at 8:03. So I'm just waiting for rest of the people to join. So meanwhile, let us revise the things what we covered in the last class. In the last class, we started dealing with the class modifiers. So what are class modifiers? The class modifiers were the thing that basically were providing extra functionality to the class, as well as the same time they were restricting the accessibility, right, from where which packages you can use, whether we are capable to create the object or not, what are the methods that will be visible. So we'll continue our discussion further on the these modifiers part today, and then we'll learn about abstract classes and interfaces, and we'll start with groups. Okay, so let us start. So in the previous class, we dealt with the public access modifier that is applicable for classes also. That if we declare any class as public, then we can access that particular class entirely through any package in our project. So there is no restriction. If we declare any class as public, it can be accessible from anywhere throughout our project. But if we declare our class as default, then it is only accessible in the current package. We saw some examples too. Now today we'll start with the final. Uh, what is final access modifier? So let us first go through the theory part of the final access modifier. Then we'll go ahead. So basically, final modifier is applicable for class, methods, and variables. So it can be applied to all these three. And let us see the scenario. What happens when we apply to all those things? So in the few moments, we'll discuss about what happens when we apply this final access modifier to classes and methods. In the further section, we will discuss what is the effect when we declare any variable as final. So, so let us start our discussion. So if we declare any method as final, okay, this method cannot be overridden by its child. So whatever I have said, let us break it down. So since we are discussing Java, and Java supports OOPs, right? It's an object programming language. So there is a feature of OOPs called as inheritance. We'll discuss all these things in detail in tomorrow's class. But just to give you overview, we'll start talking about it. So OOPS has a very important property called as inheritance. So I will explain the inheritance with the help of an example. So we all have our parents, right? They have their grandparents and their great grandparents, and this is how our generation is going on from. It's moving ahead in time. So what happens is whatever our parent has acquired, right? Whatever the belongings that your parent has is by default available to its child, isn't it? Similarly, your parent, your grandparent had some acquisitions, right? And all those acquisitions are by default accessed by your parents. So I'll give you an example. Let us suppose that my grandfather had a Rajdoot, right? You know, Rajdoot is a bike. It was a very classic bike. And after that, by default, when my parent, my father or uncle, when he was about to go to college, they can easily access this Rajdoot. Why? Because it is by default available to them. It belongs to their father, so by default it is available to them. In a similar fashion, my parent bought a bullet, right? It was a trend of bullet at that point of time. Now what I have is I have this access to this bullet because I am the child of my parent, you know. So this series continues. So whenever there is something available to the parent, this is by default available to its child. So this is called as inheritance. So here you got the abstract idea about the inheritance, but this inheritance is of great use when we are developing a program. I'll show you how. Let us suppose that I'm writing a banking application. What I'm doing is I'm writing a banking application, or let us say, let this banking application be the GUI of your ATM, right? You see on the daily basis. If you remember the prior version of these ATMs, there were few basic options like you can, let us say, you can withdraw, or you can check your balance, or you can transfer the balance. There were only few options like check balance, withdraw, or show balance. But in the recent years, now they have created one more machine by the side where we can deposit the money as well, right? There is a teller machine from where you can deposit the money as well. If you see, there is a regular upgradation. By default, these features are available to it. Along with it, there are few add-ons. So this is the advantage of inheritance. When we move successively to this class. Now think of these two terms in terms of class. This is a parent class. This is a parent ATM GUI class which have certain functionality. Now, as we have moved ahead, we have we have introduced some few features, but at the same time, we are carrying all those features that are by default available to its parent. So what I will do is, let me write in form of class. This is class ATM parent, and it has got, let me write some methods like withdraw, and it has some other methods also like show balance, right? All these methods. Now I have class child, or you can say new release child ATM. Okay, and now this class extends. When you write keyword extends, which means that this is the child class, and after extends, whatever comes is the parent class. So what is the parent class? ATM parent. Now, whenever you write like this, by default, all the methods and variables that are here are available to this child ATM. So now this child ATM have by default all these methods. Apart from it, if you want to add some of the methods here, you can easily add it here. There is no harm with it, right? So let me add one more here, like favorite transaction. So child ATM has one more upgraded feature called as favorite transaction. Okay, so this is the thing. So I'll show you the example on the console. Don't worry, this is just the explanation part. Make the intuition part very clear that what we mean by child-parent relationship. Okay, so this child-parent relationship is also called as is a relationship. Just focus on the English grammar, right? You are the parent, you are the child of your parent. So child what? It shares a is a relation, right? It is a relation that parent that You have a parent. Is a relationship. But when you date a girlfriend, you have a girlfriend, or you have a girlfriend, right? So that's a have a relationship. So always the parent-child relationship is a relationship. Keep this thing in mind. We will deal with it when it comes to inheritance. But for the time being, remember that whenever there is a child-parent relationship, it is always is a relationship. So I'll show you. Let me go to the console. Let us study about some of the theory parts, and then we'll see the practical. Okay. So what it says is, see, whenever we apply this final modifier to method, what happens? Whatever the method parent has by default available to the child, we saw that by the virtue of inheritance, whatever the methods and variables that a parent has is by default available to the child. Okay. So, but there is one more thing. Uh, let me go to the console. I'll give you example. Let us say that we have a class called as parent. We have a class called as parent, and it has a method called as show bike. Show bike, and it returns void. It doesn't return anything. It is void. And here, in case of parent, it is written here uh, Yamaha. Yamaha, it will be some model. I don't remember what I had. RX 100. So this is by default the bike that is available to your parent. So when I declare call as class child, and class child extends, so what is its parent? I'll write here parent. So by default, when we create an object of this child, so this have this so bike, it can access this method, that is RX 100. But what happens is child, since the generation has changed, this child what now is, he wants to have some different bike. Let us say he wants to have bullet. So what it does is it overrides the same method. Overriding means we are redeclaring the same method here, but now this method, the parent's method is overwritten here. If you don't declare this, by default the parent's bike method will be called. But if you declare a method called as so bike here, now when we create an object of this child, this method will be called. Now we'll see the practical, don't worry. So now here I will just declare that I have Royal Enfield Meteor. Right, Meteor 350 I have. So this is called as overriding. This feature is called as overriding. By default, if you don't apply any modifier here other than final, child class has the privilege to override the parents method. Okay, but now I'll show you one more. I'll show you there only. Let us move to the theory part. I'll show you some very interesting examples so that you remember it throughout your life. So if a child is not allowed to override, see here, what is written? If child is not allowed to override any method, that method we can declare it with final in the parent class. See, it is clear from here. The final methods cannot be overridden. So let us suppose that our parent has invested some money in some business, or they have bought some piece of land, and they don't want their child to sell that property. So what they will do is they will declare that particular selling method as final. So now the child doesn't have, it can access those properties, but it cannot sell those properties. I will show you this example. This is very example. Okay. So now let us move to the final class. What does this final class mean? If a class is declared as final, okay, so we cannot create child class. That is, inheritance concept is not applicable for final class. Whenever you declare a class as final, by default, all the variables, all the instance variables, all the methods that are present, they all change to what? They all change to final. And the sole concept of inheritance is that whenever child inherits all those methods, it changes it, it adds certain more functionality. So whenever you declare any class as final, what it does, it restricts all those properties. So there is no point in the property of inheritance. So this is what final class does. Whenever you declare any child as final, the inheritance concept is not applicable. Means that you cannot create child class. Is it clear? So every method present inside final class is always final by default, whether we are declaring it or not. But where variable is present in final class need not to be final. Okay. So all the methods will become final, but sorry, I made a mistake. But every variable present inside a final class need not to be final. So all the methods will become final, but all the variables will not become by default final. For methods to be final, you have to declare it. Okay, sorry for the mistake. Just let me correct. I just mixed two things. If you declare any final class, then all the methods will be final. All the methods will be final. Variables or all the variables is not, it will not be final. Make sure that. Okay. So now let us move to the console and let us see some beautiful examples. So let me. Okay. So let me delete it. Okay. Let me close it. So I will create a package. Let me create a package. Let me create a class parent. I'll give a package name itself. So I'm declaring area parent home.ap. Okay, finish. So what I have done here is I have declared a class called as parent. And let me declare some of the methods. Some of the methods. So let some of the methods be like void so by. So let me write here like parent have is good. Remember that old black bike? 350. I'm writing here. Let me write some more methods like void property. So let us suppose that my parent has bought some property. Let us suppose that I have 2.5 acres of land that they have bought. This is and let me add one more interesting method. Like let me write void child's marriage. Whatever their child is, let it be anything, and whenever they have this is their son, and what they did is they fixed their marriage in his childhood with some girl. Let it be Hemlata. So marriage to Hemlata. So they fixed in the childhood. Wait, let me write here marriage fixed in childhood. I will show you this example. You'll never forget after this what is the effect of final. Now let me create one more class. Let this be child class. Okay. So I'm creating one more class as called as child. Now what this child is doing is it extends. Extends what? It extends parent. So I have just extended the parent. So what does this mean? This means that all the properties that are available to this parent is by default to this accessible to children. So let me declare some of the variables like in so family title, right? Let me write. Right. I'm just giving a family title. You know, we all have a name title. So let me put here right Srivastava. Okay. Similarly, it should be string, right? So let me put one more example like int. This is the pin code, the address that we share. 43113. So these are the variables. Now let us go to the child class. Let me create a main method also here. Okay. Now let me create parent object here. Parent equal to new parent. Now see, using this parent variable, I can access all the properties and the methods that is available here. Okay, I'll show you. Parent dot show by. I'll run it. Just observe the logs. See, Rajdu 350cc. Let me just zoom in a bit. Appearance, editor, zoom in. So you can see what is here. Rajdu 350cc. You can see that easily here. Similarly, let me show parent dot show property. So whatever the property that my parent has acquired. So this is 2.5 acre of land that they have bought. So these are all the things that parent has. So you can easily see that I have created an instance of the parent, and these are all things that are available. So let me write parent dot family title. I will show you that family title is also accessible from here. That is Srivastava. Now let me go to this child. See, I have not declared any method, variable, anything here. So now what I will do is I will create the instance of the child, and let us see child equal to new child. So I have created an instance of the child. Now let us see whether all those methods and variables that were declared for the parent are accessible from the child. So let us see. So child dot. Now the first thing is that let me show the bike. So I am writing here child dot show bike. Okay. And I am also printing here one more statement so that you don't so ensure that it is from the child's main method. Child main method. Okay. I will run it. See, child's main method, this is Rajdu 350cc. And from where we have accessed this? We have accessed these things from the parent. Okay. So you can easily see that whatever is by default available to the parent is the child class can access it. If you don't write any other modifier, this is by default. If you don't write anything, this is default access modifier. And we can easily access all these parent things. Now let me do one interesting thing, what I was telling you. Now I will again declare the method called as show bike again here. See, it is written here override at the rate of override. If you don't write anything, it will by default call the parent one. But let me just override this method. This is called as overriding. And I am writing here Rajdu. The Rajdu, no, let me write bullet. Bullet meteor. Okay. See, I am where if I call the child.show bike, you see which method gets called. See, bullet meteor 350cc. So what I did is by default, let me write here. By default, my parent has what sort of bike? They had Rajdu. But when I didn't overrode this method, the child also had Rajdu. But now child has become smart. So what he did is, he just override that method. Means he redeclared the same method here. If you see, the entire method is same. So by see the observe see here observe this so by and observe this so by here. So by and this is Raju 350cc. So so this was the uh, so this was the concept that I want to tell you what is overriding. So overriding occurs when the child also declares exactly the same method as that of parent. Okay, and this method that is available in parent class is default or public. Okay, then only. If it is final, then the scenario will be different. Okay, now let me give you the example of the final keyword. What happens when we declare it as final? So I'll tell you a story for that. So I have a friend called as Nagendra. So what happened is when he was born, right? He was 5 to 6 years old, and he's from a village area. So what happened is their parent fixed his marriage in the childhood. That now at the age of 5 to 6 year only, this boy has got engaged to some girl called as Hemlata. Okay, now all the thing is done. The marriage is fixed. Imagine this that this poor guy that he's just 5 to 6 year old. So what he can do? He cannot do anything. Just he's enjoying the thing. So let me show you that what happened. So this is the parent class. So what parent did is they declared this as final. Means the now marriage is fixed. Now he cannot do anything. That when he grows up, so he have to marry that. Now I'll tell you the story. But he is a very genius boy. Now he went to the college and he studies very well and he topped all the exams and all. So many girls around him. So he fell in love with one of the girls. Let us assume her name is Prem Lata. His marriage is fixed to him Lata, but now he has a girlfriend called as Prem Lata. So the thing is that I'll show you. Let me come to this child class and let me call this method called as child dot show marriage. Okay, is that good method called as marriage? Child marriage. So that child dot child marriage. Now if I execute this method, what is it? Marriage to Hemlata. This is fixed. Okay. Now let me just omit this final for the time being. Okay. Now, if the method is not declared as final, what this Nagendra can do is by default by default his marriage is to with whom? Hemlata, right? It's not final. They have just discussed it. But so this gives privilege to Nagendra that he can override that method. Let me write here. Why is it going like this? Let me copy this file and let me write it here. Now, Nagin has the privilege to override it. Now, okay. Now let me run the method. See, marriage to Premlata, he's in college. Okay. If I comment this, see what method is called. If I comment it, the method that is called is marriage fixed in childhood, marriage to Hemlata. But what his parent did is they declared this method as final. Now there is no scope. Now he cannot do anything. See, if I run it, observe the logs. What exceptions occurred? Okay, hang on. I think there's some issue with this run as the application. This crashed actually. Well, just hang on for a while. I think it has crashed. Just wait for a while. Why is it showing all? Okay, I like again put that example. Don't worry. Some problem with my version. Just hang on for a. We'll do that within few minutes. Okay, so these were the two methods. Okay, I'm back with it. So let me create an instance of the child now. Okay, child equal to new child. Now let me call the method that are by default available to the parent. Child dot so by. Okay, so I'll show you this. See, Raju 350cc. Now we are discussing the overriding concept where the child has the privilege to override the by default method that are available to the child from the parent. So that was the method called as so by. I will override this method. So this will be by bullet 350 cc. Okay. Now you see when I override this method, it has changed from Rajput to bullet 350cc. But if see this so marriage example again. So let me call this so marriage method again and show you the difference. Child dot so marriage. See, it is marriage to Premlata that has been fixed by the parent. So this is parent's wish. But if the child doesn't agree to it, he can easily override it. Void. What is the name of the method? So marriage. See, marriage to Hemlata, it has been changed. But imagine if the parents are strict, what they will do? They will put it to final. Now, if they put this to final, you cannot override it. See, you'll see a remove final modifier of parents so dot marriage means if the parent has declared any method as final, you cannot override it. Now you have to abide by the decisions that they have made. You cannot override it. So this is the power of final. Okay, I'll show you one more example. Let us say they have um, they have declared that some method called as property. Right? They have invested in some business. Right? Now, let us say they have a business called as EdTech. Now they have Floxus Education. They have Floxus Software Limited. This is the company they have. So now what happens is its son also want to do some business. And let me copy the method from here. this method again. So his son also wants to do some business, and what he does is he just shut down this company, shut down this company, and he wants to start something of his own. Just say he want to start. He want to build some, let us say, aerospace. He wants some aerospace company. So if parent has not declared this method as final, so it gives the chance to the child that he can override the method. So let me wait. Dot business. You see, just you observe the output. This is aerospace company. Okay. If I just comment this out, observe the output. This is Floxus Software Private Limited. So if the child doesn't want to start a business, by default, he acquires the business of the parent. But he wants to start the business, he can easily override it. So this was the thing. Now, what parent did is they have invested a lot of time and labor into it. So they don't want their child to shut down the business. So they declare it as final. Now, if you see here, let me run it again. Please. So, so he cannot do it. So this is the thing. So you have to declare it. You have to remove this final from here. Then only this child can override it. Okay. So I hope that the difference between final, what are the things that final method can do is clear to you now. If a parent declares a child, any one of the method as final, the child does not have the privilege to override it. If the parent has not declared any method as final, child can easily override it. It can write its own implementation. So this was the thing about if we declare any method as a method with final access modifier. Okay. So let us move to this final class. See, let me remove all these methods called as final from here, and I will show you. Now, instead of public class, let me write here as final class. Okay. So this is now final class. You will see here that there is yellow button here. The type child cannot subclass the final class parent. So all these methods, first thing is that you will see here whenever I am writing public class child extends parent, I am getting here yellow button here, yellow pointer here. It is saying that the type child cannot subclass the final class parent, which means that whenever you declare a class as final, the whole concept of inheritance, you cannot have child class of it. So the whole concept of inheritance comes to an end. So this is if a class is declared as final, then we cannot create a child class. That is inherent concept is not applicable for final class. Remember this. There are many instances when you study about design patterns, we will use this concept of final class. Means if you move into development, there are many instances where we use final and private classes, all these things, even private constructors. So the concept is important. Remember this. Okay. So the main advantage of this is security. If you declare any class as final, so nobody can alter the methods, nobody can alter the variables of that class. But at the same time, what final keyword does is that it prevents the creation of the child class object. And one of the important feature of OOPS is inheritance. That the class that is once created can be inherited again and again. So in one way, it gives you security. And on the other side, it curtails the benefits that is provided you by the OOPS. So this was the advantage and disadvantage about the final class. So the next access modifier that we are going to discuss is abstract modifier. So before starting the abstract modifier, let us talk about what we exactly mean by abstract in English, so that the meaning becomes very clear to you. So, in anything that is just an idea, anything that is just an idea that does not exist in the physical form, or it's just a logical thought, right? It's an idea or an means unimplemented idea or doesn't have any logical existence, physical existence. It's called as abstract. Huh, right? We say all the emotions like love, affection, kindness. There are all these are all abstract things, right? There is no physical existence of things. Similarly, in Java, there is access modifier called as abstract. So whatever the classes that we have seen so far had implementation, right? We can create uh, objects of those classes, but there can be instances that I'll give you an example to make that thing very clear. Suppose that I'm building some application, right? I'm developing some application, and I have certain features here, but I just thought of some of the features, right? I thought of some of the features, but I exactly don't know how to implement it, right? So what I will do is I can just put that method here without any body. Means this method will not have any implementation. Okay, so this will have just the body so that it can guide the further releases of this application to develop this feature. So this is what abstraction means. When you don't know the implementation, still those things can exist. So this is what we mean by abstraction in Java. Okay, so let me go to the theory part now. So I've written here that what abstract means. So any thought or an idea without concrete shape is an abstract. So basically, this abstract modifier is applicable only for methods and classes, but not for variables. Right? Methods and classes are the things that can be idea without any implementation. We can declare classes without implementation. I'll show you the examples. Okay, so let me give you some examples of it, then things will be more clear. See, about assignment, you can submit it in any form. You can submit it in a doc file or a PDF file. What you have to do is that you have to write all the answers. If you have wrote all the codes properly, just copy the code from the editor and the output, and just submit the assignment. And please don't miss the deadline. If you miss the deadline, the assignment will not be considered. The deadlines are very important. You can submit it in any form, either in doc or in a PDF file. What you do is copy all the codes in a single doc file, separated by some special characters so that we can understand that the questions are separated from each other, and this is how you can submit. So let us move to the topic again about abstract modifier. So we understood from the intuitive part, the discussion, that anything without implementation is called as abstract, right? We don't know the concrete thing about it. So I will show you with the example. So let us take an example that I want to develop a banking system. Let us say, uh, let us say not banking system. Let us talk about accounts. Different type of accounts in a bank. Accounts in a bank. So there are various types of accounts in a bank. There are current account. There are savings account. So let us talk about just these two types. This current and savings account. Now what it does is these two these two current and saving account have some common features. Okay, these are some common things that they share, and apart from it, they have some special methodology and functionality of their own. So here I have something called as loan account. There is a loan class that tells that what are the things should be there in the loan. The first thing should be the name of the person who has taken the loan, the bank from which it has taken the loan, what is the amount. Okay, okay, sorry, I just mixed up loan with account. Sorry about it. So there are few things very common about account is that the name of the account holder, the bank in which it has the account. Apart from that, what is the amount they have. Okay, so these are the things. But apart from it, there are certain special functionality that current and savings account offer. There is a difference between the interest rate. There are different service charges for both of them. So, so we will implement these things using an abstract class. That how this abstraction help us to achieve these all sorts of functionality. Okay, so let me move to the console now. Just delete this. So let me create a class called as account. This is a common account. It will have certain functionality. Instead of public, what I will write here is abstract. Means we do not have direct child of this. ABS, this is abstract class amount. So this is just an idea how account should look like. So let me put some of the thing here, like string. So account holder. Who is the account holder? String. Let me put here bank name. What is the bank name? Let me put here branch name. Let it, let me put here amount. What is the amount? So these are the very common things that account can have. So let me create a constructor also. Let it be. For the timing, let us not create the constructor. So this is the account. Now let me create one more class and let this be savings account. Savings account. So now I have a savings account and this savings account extends what? The account. What's wrong with it? Syntax on token. Okay. So now this saving account has extended account. Okay. So which means that all those things that are by default available to the account is now available to the saving account. But apart from it, it has some important some variable called as in. Let me write as interest. So what is the interest that we are charging? Then let me create a main method here to show you the example. Let me create a savings account is equal to new savings account. Let us see what are the variables that we can access. So let me put some default. I will put that account dot now account holder. Who is the account holder? Let me put here name as show. See, this account holder is not declared in this savings account because where it is declared in this account section. So all these things are by default available to this. Okay, and let me put again some of the things like account dot. Let me branch name. So let it be SBI. S dot B dot I. This is SBI. Let me put some other details like account dot amount. So we have just 500 rupees in the bank. Is there any other thing? Okay. Let me put one more thing. Account dot interest. What interest the bank pays me? This is a savings account. The bank pays me like 6.5. So let me convert to bracket. So these are the things. If you see carefully, this account holder, bank name, amount, all these things are by default available here in this account. Okay. Let me put one more thing. Account dot branch name. Branch name equal to Mesra. We have declared just one thing interest here, and all these things are now available to this savings account. So let me create one more class called as current account. Current account. So this is current account, and they also have their own variable called as interest. Since they both are common, we could have grouped it in the account only, but just for the sake of showing you the example, I am doing this. Okay. So what I will do is I will create a instead of saving account, I will create a let me change here to Canada. Because SBI, but now the branch has been changed to Mountain West. Now what we have is 5,000 rupees interest of in is to double. The interest is less 3.5. Okay. Now what I will do is since we know that abstract can be applied to class as well as method. So I will create a method here, abstract method. Abstract, and this returns nothing void and show account type. What type of account do you have? See, as I have written here abstract void show account. So as I have declared it as abstract, I don't need to write the implementation. Otherwise, if you remember from all the previous classes that we have developed, let me put one more here. One more create one more method here. Void. Let me write greet. Greet bank greets us. Right here. How does bank greets us? So, hello plus account folder name. This is how bank greets us. You see, this is not an abstract method, so we have to define the body. You see the difference between these two methods. The first one does not have any body. It's just an abstract method. So what does this abstract method do? This abstract method actually provides a guideline. What it is doing is, it is providing a guideline to all the classes that is inheriting this accounts class. This account that whenever you create a concrete class of this class savings account, it is mandatory that you have to declare the unimplemented method. So what was that unimplemented method? See, here we have an unimplemented method called it show account type. So we have two implementations, savings and current account. Now these two accounts need to provide the implementation, the body of the method that we have declared as an abstract. So what I will do here is I will write here so and this is savings account. Okay. In the similar fashion, we'll go to the current account. This current account, see, this current account has so far not extended the account class. It is not showing that we don't have any unimplemented method. But as soon as we extend the account class, there is a small bulge button here that is showing here that you have to add unimplemented method. So I have to declare this method. So this becomes compulsory that now I need to provide all those abstract methods that we had declared in our abstract class. So what I will do here is I will write here system.out.println and let me write here which account type, current account. This is current account. This is current account. Okay. So this is something I want to let me create one more class as test. Class test. Now here I will create the objects of all those two classes. What I will do is I will just remove this main method from here. I'll just copy all these things from here. We'll put this inside test. Let me just remove this main method. Just I wanted to show you that is why I have written. Let me again do the same thing. Let me copy this from here. Let me put here. Let me write here count one. Okay. So what I will do is let me just quickly summarize the things what I have done. So far we have an abstract class. So what is this abstract class? This is basically a account, class account, which provides some general instance variable, one concrete method. Concrete method means that have an implementation. So one concrete method called as greet and one abstract method. This what does this abstract method does? Whatever class that extends this account class will have to necessarily implement this guideline, this method. So we have two implementation classes of this account class, that is savings and current. Okay, and all these two, this abstract method was so account type. So we have just overridden this account type in both the places to show what kind of account do we have. So what this is the scenario that we have dealt so far. Now what I am going to do is I am going to create a class called as test, and I am going to create two classes of this two objects of this class. One of the savings, one of the current, and I will show you that for each of these class we have provided different implementation of the methods and how the output comes to be. Just see the implementation of both the classes. So I am here in the test. So right now I have two objects. One is a savings account object. One is a current. Let me make it current. Current. Okay. The saving account which has to be current account. Now let me print what account dot show type. Just so account type account one dot show type. Now just observe the logs. See, it is showing this is a savings account and this is a current account. Why is it showing like that? Because we have two different implementation of this account abstract class. So this is how abstract class help us to. If you want to write some of the general code at one place, and if you want the child classes of those classes to develop the further functionality, we use our abstract class. So this you can write a lot more example. I will give you example of a university. Right? We can develop the abstract class called as student, and we can provide basic features like name, ID, branch, blah blah things. But at the same time, we can provide implementation about syllabus. Now, for syllabus, so this could be one of the thing. Then we can write placement companies, one of the method. So, or we can declare all these things as abstract. Means whichever whichever class implements this student will have to implement this. Right. For example, mechanical students implement extends this student class. Now they will provide their own implementation for the syllabus. Right. They can provide their own implementation for placement. They will put all their syllabus here, and for the core companies they can put their own list of core companies that are going to come. So this is how abstract class helps. What it does, it just puts all the common feature and functionality at one places. Okay, so this was the thing about abstract class. This was the example, just a common example that I wanted to show you. Now let me discuss some theory part that are important. First thing is that you cannot have a direct child of abstract class. Means you cannot create a child of abstract class. For creating of a child of abstract class, you need to have an implementation. See, I will show you. Account. Let me write account to equal to new account. But this is not possible. But in Java, see, it is an now it has become an anonymous class. So don't go into the detail of anonymous class. But you cannot create. You can create anonymous. We don't have to discuss this functionality now. So see, you cannot create a direct child of this class. Means you cannot create a direct child of the abstract class. It will throw error. See, cannot instantaneate the account object. See, if I run it, I will get errors in the logs. Cannot instantaneate the type account. Why? Because this is an abstract class. We cannot have an implementation of the abstract class. So remember this. But we can hold the object here. Right? New savings account. See, now this account reference is holding up. We'll deal with it when we come to when we'll discuss about late binding and early binding, how references matters. Then we'll discuss about it. How this parent reference class is holding this child object. Okay, so we'll discuss about it, but not at this point of time. Maybe on the last day we will be discussing this thing. So you cannot create a direct child of abstract class, but you can hold the child class in the abstract class reference. See here what you have declared account 2, which means that you have a reference variable of account type, that is the abstract class. But the child that you are the object that you are passing here is of the child class, that is savings account. So you can hold this child object in the parent reference. Okay, but here you are not creating an object, direct object of the parent class. You are creating the object of the parent class via inheritance. Okay, so remember this rule. This is a mandatory rule. This is a Java based functionality, so you need to remember this. So even though you don't have an implementation, still we can declare a method with an abstract modifier. See, there are one more important thing that you need to understand, that abstract class can exist without any abstract method. If you have an abstract class, so it is not necessary that this class must contain an abstract method. This is not mandatory. But if you have an abstract method, then it is mandatory that your class must be declared as abstract class. See, I'll show you this example. So let me create. Okay, let me go to this account section only. Let me just comment this out. Control Shift T. So see, this class does not have any abstract method, but still the class can be declared as an abstract method. See, there is a bulb that showing a notification that the type account must be an abstract class to define abstract method, which means that if a class contains at least one abstract method, then it is compulsory that we need to declare that class as abstract. Okay, so this was the thing. Okay, so these are few points about that abstract method have only declaration but no implementation. We have seen that the main advantage of abstract method is that by declaring an abstract method in parent class, we can provide guidelines to the child class such that which method they should compulsory implement. So we have seen this example in case of uh, the bank account type example that we were seeing. So now child class is responsible to provide the implementation for the parent class abstract method. So we have covered all these points in our example. So this is the syntax that we need to follow when we are declaring a abstract method. If you put this to curly braces, which means that you are providing a blank implementation. So we are not, this is blank implementation. But in Java, you are not allowed in Java, you are not allowed to put this implementation if you declare this as abstract. Since you have declared it as abstract, which means that it can contain only the declaration, not the implementation. So once you declare this implementation, even it is blank, so it will become abstract. You cannot do that. So let me move to this abstract class theory part now. That what does this abstract class say? So for any Java class, if you are not allowed to create an object, such type in those all scenarios, you need to declare it with abstract modifier. That is for abstract class instantiation is not possible. So remember this point. We have seen that we cannot create a direct object of the abstract class. We have to come through the object part. But you can store the child class object in the abstract class reference. This is permitted. Okay. So this is thing. If a class extend abstract class, then compulsory we need to provide the implementation for every abstract method of the parent class. Otherwise, we can declare child class as abstract. So this is. Let me give you one more example so that you can understand it. So we can have multi-level abstraction. Multi-level abstraction. So let me give an example about multi-level abstraction. Let us say we declare some class as parent. Have declared class as parent, and when we have declared some abstract methods here, I have declared some abstract methods here. Now what I did is class child extends parent. So if we make a concrete class, means if we have not provided abstract here, which means this is a concrete class. So in this case, I need to provide the implementation of this abstract method that we have declared in the child class. But what we do is if we put here abstract keyword, you have the freedom that either you can provide the implementation or you can again redeclare this method as abstract. Okay, so this is called as multiple level of abstraction. So now if you declare this child class as abstract, you have two possibilities. Either you provide the implementation or you can continue this method to be abstract. And the further implementation maybe like class like grandchildren, when they extend this child class, they provide the implementation for all the abstract methods from the further level. So this is one of the things. See, you try this. Okay. Now there is an important uh, point to discuss. I have already discussed it, but I have written here what is the difference between abstract class and abstract method. So remember, guys, if a class have at least one abstract method, then it becomes mandatory that you declare that class as abstract. But it is not mandatory that if you have abstract class, then it must contain some abstract method. Remember this point. I'll repeat this again, that if a class contains some abstract method, then it is mandatory to declare that particular class as an abstract class. But it is not mandatory in case of abstract class that you have to declare some abstract method. So remember that it's one way relation, it's not both way. So see, I've written if a class contains at least one abstract method, then compulsory the corresponding class should be declared within abstract modifier, because implementation is not complete and hence we can't create the object of that class. Even though the class does not contain any abstract method, we still declare the class as an abstract. That is, an abstract can contain zero or no abstract method also. Okay. So why we are doing that? That abstract class can have no abstract method, because we want to group some of the common functionality at one place. Right? There might be question in your mind that though you haven't provided, let me, I have a class, like some class test, and it have all the concrete method definitions and the instance variables of this class, and still you are declaring it is abstract, then what is the point in doing that if it doesn't contains any abstract method? So what is the point in declaring this as abstract? So the point is that there are requirements where we want to group some of the common features at one place. For example, if we want to group some of the common functionality of the student at one place, or you are working on some requirement uh, where you want to group all some of the common feature at one place, and further all those who extends this abstract class have at least these all features. Apart from this, they declare some of the advanced features in it. So this is the advantage of using abstraction. Okay, to provide some common functionality to each of its implementation. This was the advantage of using an abstract class, even though it doesn't have any abstract method. Okay, so this was all about abstract class and abstract method. So let me move to now member modifiers. So we have declared all about so far about the class level modifiers. Let me discuss something about member modifier. So we have seen some of the things earlier also, like public member. If you declare anything as public, so it is visible all throughout the entire project. If you declare some of the member as public, so we can access its visibility is all throughout your project. In the similar fashion, if you declare some member, here by member I want to say the types of variables. Okay, the types of variable like instance variable, static variable. If you want to, if you declare all those as default, which means that we can access all those variables only to the package level. Similarly, if you declare any variable as private, which means we can only access all those variables only in the class. So I will show you this example about these private members. So let me come here. Let me do one thing. Let me close all these things. Let me make one more practice. Form dot dot form dot Floxus. My second package. Now what I am doing is I am declaring a class called as parent. So let me declare some of the variable like int. Let me say this is the parent name. So let me write something here. Let me write Let me write what a property. How much property there? Let me write in bike. Let me assign some of the default values. Let it be 10000. Bike to be okay. Let me put some other things like like ventures. What are the ventures your parent has? So we have Floxus education. Let me put some word. So let me put some methods like word. So places visited. So friend here like Agra, Agra, Delhi, Leh, Ladakh. So these are the things. Let me create a parent, a child class, not class, but let me create some test main method. What I will do is I will create a object of this parent will be named parent. I created this, let me write parent dot so places will depend. Just observe the log. Agra, Delhi, Leh, Leh. Similarly, if I write for yourself, parent dot bike. This is Rajdu. Now what I will do is I will just change some of the modifiers. So let me just make this private. What I have done now is that I have declared this bike as private, which means that you can only access this private only within this class. You cannot access outside this class. See, now since I am outside that class, right now I'm in test class, I'm trying to create an object of the parent class. So when I will run this, the field parent.bike is not visible. Why is it not visible? Because the private modifier restricts the accessibility of the variables only within the class. So now you cannot access all these variables outside your own parent on the own native class. And let me show you that if I declare a main method here and I just create a parent object, if I try to access this bike, I can easily do that. Why I can do that? Because I am within the same class. So this is what private does. See, here I can print this Raj2. But if I go to this test class, I cannot print this bike because this private modifier on this variable has restricted the access of this variable instance variable bike only within the class. Now you don't have the privilege to access this variable bike outside this parent class. Okay. In the similar way, if I make this method as private, see, if I make this variable as private, I can access this. I can access this method within this parent class. So I will write here parent dot so places to visit. See, when I am inside this parent class, I can easily see. But if I go to this test, And if I run this test, see the output. Exception. The method so places from the type parent is not visible. The field parent.bike is not visible because we have put this private access modifier over there. So private access modifier, what it does is it restricts the accessibility of the instance variable and the methods only to within the class. So it restricts the scope of the access. Okay. We will see the advantage of using the private modifier when we will studying about method hiding. Most probably tomorrow we will be doing that. That was the first topic that we start with. So you will come to know the more uses of this private access modifier. Okay. Now let me come to this protected members. What is this protected members? So protected is only applicable for and methods and variables. Class cannot be declared as protected. Remember, protected is an access modifier that is applicable only for the methods and the variables. So what it does is it has very interesting thing. You can access all those methods and variables within the same package and in the other packages only via inheritance, which means that if you want to access the methods and variables that are declared as private access modifier to the parent, you have to create the child object in the other package. So let me uh, go to my whiteboard. So let us say I have some parent class. Let me declare some package like form.ap. Now here I have a parent class, and in this parent class I have declared some of the variables and method as protected. So which means that I can access these methods and variables within this same form.ap package. Means you can access all these variables easily as we used to do in the using a default access modifier. But if you want to access form.ap, if you want to access this variables and methods outside this form.ap package, so let me declare it as form.floxus. So to access these two methods and variables, here you have to create a child class of this parent, which you have to create a class called as child, which extends parent. Okay, so this is mandatory, and there is one more thing is mandatory. We cannot use parent reference to call protected members from outside the package, which means if you remember that in case of abstract class or even in case of inheritance, we are allowed to hold the child object. Means if I write here like this parent p equal to new child. So what we are doing here is that we are using a parent reference. This is the reference variable to store the child class. So in this scenario, if you want to access these protected members, it is mandatory that you don't use this parent reference variable. What you do is you have to, it is mandatory that you use this child reference variable. Then only you will be able to use access this protected members and variable. You will see the example. So this was all about the concept. Let us see the implementation with some example. So, I will do one thing instead of this. So, let me use this private one here. I will do one thing. Let me go to this account.java. No, don't account.java. Let me create one class here. So let this class be student. Student. Okay. Now what this class has is, let me write here string first name, string last name, string phone number, and and protected branch name. So this is the thing. This is my protected string branch. So let me do one thing. I will declare rest of the thing as public. This means I can access it anywhere throughout my project. I can access all these instance variables throughout my project. But there is one, this is called as protected string branch name. So let me declare two methods also here. Void, and let me write as say hello, hello student, and I have a protected memory. Void, declare protected void, and say hi. So I'm just putting all these examples to demonstrate the thing. I'm putting a protected void, say hi. So what it does is SYSY. Let me print here hi from protected method. So hi from protected method. Now let us see. In form.ap we have a class called a test.java. So what I will do is I will try to create the object. So let me just I have just commented on everything. Now I am creating an object of student equal to new student. So let me do one thing. For the sake of convenience, I'll assign some default value to it. So you can instantiate all these variables using constructor. I taught you how to use constructor to initialize the object. All those things you can do by your own. I'm just providing this by default value. By default, the branch name is MNC. So these are the things. These are the default values available to it. So right now, what I'm doing is I'm creating a student object and let me print the value like student dot say hello. See, has printed hello dot at the same time and info dot student student dot let us say let me print some value like first name. I can easily access all those values from here. I can easily access let me write branch name MNC. Okay, so this is the thing. But now let me go to this test.java. This is from form.ap package. Now what I will do is let me copy this. Let me close rest of the thing. And here test.java. This is in different package. So what I will do is for the sake of convenience, let me print here that I am in form.Floxus package. And let me write some of the things like say hi. Okay. What are the things that were available? And first name is available to me. So Let me write it here. First name. Let me. What was the name of the method? Say hello and say hi. So let me make it public. Student dot say hello. Just I will see. I am informed of, but see the variables and the method that we are allowed to access. So far, what I have accessed is public. Now let me access this protected thing. So what is protected here? Say hi. So now instead of say hello, I will write here say hi and I will run it. Just observe the log. The method say hi from time student is not visible. Why is it not visible? Because it is declared as protected. So protected behaves as what? Default in the common package, but outside the package you have to access all these values using only the child child reference. So what I have to do is I have to create now a class called as child student. So this is actually a child class of that student class. So I have created child student and now this is going to extend what student. Okay. So I have declared this. Now let me go to this test. Now instead of student, I will create an object of child student. Now just to see the magic. Not magic, but child student equal to new child student. Now I will run it. If you sorry, I cannot but about variable, see the variable part. Student dot branch name. Print this branch name. That was protected. Why can't I access it? Save it. Public class challenge and student. Why is it like that? Child student. Why is it behaving like this? Student dot protected member. Protected members can only be accessed in child class. Why is it behaving like this? Why? Why like this? Why is it doing like this? It should be also- Why is it behaving like this? Read this. I don't know why. Sometimes it behaves like mad. See here I can access it. Child student dot branch name. And the branch name was a protected member. If you remember that in the prior example that we were seeing, you cannot access the same. If I try to create now, you see, if I want to directly create the object of this student class only here, you cannot access it. Student, student, like student, like parent student. Or let me write the student equal to new student. Now, student dot, right here branch name. See, when I run it, field branch student dot branch is not visible. Why? See, this student class has the declaration of this branch name as protected, which means that either we can access this variable in this class only, in this package only, but outside this package, since we are in com dot Floxus package, and this student class is declared in com.ap package, so we can access this static, this protected value only within the same package, or if we want to access this protected method or variable outside this com.ap package, then it is mandatory that we have to create the child class. So here we have created a child student that extends the student. Okay, so this is the child class of the student, and using this child variable we can access the protected method as well as the variables. So this was all about the protected static modifier. So this is how, so there is one more final variable. So I will just discuss this in a very quick manner, and then I'll bind up the class. So I don't have to discuss much into it because I have already discussed most of the thing about it. Whenever, if you remember the rule of declaring the variables, if you remember the rules of declaring the variables, various kind of variables like static, instance, and local variable. So it was by default JVM used to provide the default value for this, right? According to the data type. And for the local variable, it was mandatory for us to provide the default values. But whenever you declare any variables as final, it is mandatory that now you need to initialize all these variables. It doesn't matter whether it is static, instance, or local. Okay, so this is the important point that you need to take care. Otherwise, you will get a compile time error. So this was the thing. And okay, next thing is that if you declare anything as final, you cannot change its value. If you declare a, like final int x is equal to 10, now you are not allowed to reassign some value to it. You cannot reassign anything to it. It is fixed. So this was about final variable. So this is written here about final static. For whatever I have said is just written here. For the static variable, it is not required to perform initialization explicitly by JVM. Will provide default values. But if the static variable declare as final, then compulsory we should provide the initialization explicitly, whether we are using it or not. So these are the things that I have written about the rules. We have already dealt with the static modifier. That static modifier is something when we want something to belong to the entire class level. So by one final point, I will conclude today's class that the level, this is the level of visibility. If something is declared as private, so it is only accessible within the class. If you want to access something only within the class, if you want to access something within the class, go for private. Private is for class level accessibility. If you want something to be accessible only within the package, go for default. If you want something to be accessed within the package plus outside the package using kids, or you can see the child classes, then you should go for protected. If you want something to be accessible throughout your project, go for public. So this was the crux about the entire access modifiers, and we have seen a lot of things, and we have discussed everything in great detail. So there are just minor things that I have left, and I have covered almost everything. So from the next class, we'll talk about the interface, and then we'll talk about all the pillars of OOPs. For the last two classes, we'll discuss about this OOPs concept like data hiding, abstraction, encapsulation. Now you are perfectly ready to jump into all these things. So all those things that I have discussed in the rest of the five class are actually the prerequisites that is required to study OOPs properly. Otherwise, you will keep on jumping like pendulum. Go to basics, then again come to OOPs, then again read some of the topic, and again go back to the basics. So what I have done is I have covered all the entire your basics part. Now, if you even if you don't need me to study you, now you can understand all these concepts by yourself easily. So thank you so much for the patient hearing. Uh, have a great day ahead. Have a great night. Keep coding. Stay safe in this pandemic. So I will just end the stream now. Thank you. Good night.